Welcome to part 2 of my talk on redox reactions in organic chemistry. In this part, I will be talking about how you determine if a particular reaction is a redox reaction or not, once you've assigned oxidation numbers to all of the atoms. In the previous part, part 1, I talked about how you assign oxidation numbers, so I'll assume you know how to do that. So how do you determine if a reaction is a redox reaction or not? Well, it's a redox reaction if the oxidation number of any of the atoms changes. In fact, you're going to have two change because one has to gain and one has to lose. And so you'll always have an oxidation and a reduction. But if anything is changing its oxidation number, then you know it's a redox reaction. Now there's one exception, and that is if within a particular molecule, without anything else changing, something increases and something else decreases in the same molecule, then that's not considered to be a redox reaction. Any atom that increases its oxidation number is being oxidized. It's becoming more positive or less negative, and that's considered oxidation. That's losing electrons, and so whatever substance that atom is a part of is the reducing agent. So whatever atom is being oxidized is always part of the reducing agent. Similarly, any atom that decreases its oxidation number, in other words, becomes more negative, goes down, or less positive, goes down, is being reduced, and it then becomes part of the oxidizing agent. So the reduced atom is part of the oxidizing agent. The oxidized atom is part of the reducing agent. So let's take a look at this particular reaction and see if it's a redox reaction or not. So what I would ask you to do is pause the video for just a minute and assign oxidation numbers to each of these atoms. Okay, welcome back. Hopefully you have assigned oxidation numbers to the atoms, and what you will have found is that this carbon is a -2 oxidation number, the hydrogen's a +1. Notice that I've only written the +1 one time. I could write it twice because there's two hydrogens here, but what I don't want to do is write a +2 for the two hydrogens. Each one of them is a +1, so we write it as a +1. This carbon again is a -2, this hydrogen's a +1. Notice that this kind of hydrogen is a 0 because it's part of the element hydrogen, and those are always 0. This carbon now has gone to a -3, hydrogen +1, this carbon -3, hydrogen +1. So has anything changed? To be sure, the carbon has gone from a -2 to a -3, so it's decreased, so that's a reduction, so the carbon is being reduced. And at the same time, this hydrogen has gone from a 0 to +1, so it has increased its oxidation number. Really, it's lost electrons, and therefore that's an oxidation. So this hydrogen gets oxidized, the carbon gets reduced. Since the carbon is reduced, this molecule is the oxidizing agent, and since the hydrogen is oxidized, this is the reducing agent. To put it in context, you know this reaction. This is one of the first ones we learned in first semester. It's called hydrogenation of alkenes. At that point, we didn't refer to it as a redox reaction, but it really is. Notice that it's the carbon group that's being reduced, and so organic chemists refer to this as a reduction, even though in fact it's both an oxidation and a reduction, as every redox reaction always has to be both an oxidation and a reduction, but we call it a reduction because it's the organic part that's being reduced, and that's how organic chemists look at the world. Okay, let's look at this reaction. Now first of all, notice it's not balanced, and it doesn't even have everything in it that needs to be in it because I haven't said what any of the byproducts are, and of course there has to be something else here because you can't just have a +3 on one side without having something positive on the other side. But it doesn't matter as long as we know what the things are that are changing. And so I'm just giving you the bare bones here to see if you can identify what's being oxidized and what's being reduced, what the oxidizing agent is and what the reducing agent is. So again, pause the video for just a minute, assign oxidation numbers to all of the atoms on both the left side and the right side, and see what's changing. So pause the video for just a minute. Welcome back. Hopefully you've assigned oxidation numbers to all of the atoms, and this is what you've come up with. So since these hydrogens are each +1, the carbon has to be -3. Since these hydrogens are each +1, as is that one, and the oxygen's -2, therefore this carbon has to be a -1. The oxygens here are each -2, and therefore the chromium has to be a +6. These hydrogens are each +1, so the carbon has to be a -3. This hydrogen's a +1. Each of these two oxygens is a -2, and so the carbon here comes out to be a +3. And of course the chromium here is a +3 because that's its charge. So what's changing? Well, clearly the chromium is going from a +6 to a +3. That's a decrease in number, so therefore that's a reduction. So chromium is undergoing reduction. And this carbon is going from a -1 oxidation state to a +3 oxidation state. So it's becoming less negative, more positive, increasing the number. That therefore is an oxidation. So this carbon going from a -1 to a +3 is undergoing oxidation, and it's the other thing that's the oxidizing agent. In other words, it's the chromium oxide that is making this be oxidized, so this is the oxidizing agent. So organic chemists refer to this kind of reaction as an oxidation because it's the carbon molecule that's becoming oxidized. And so we call it an oxidation, even though, of course, something else is also being reduced, as long as it's the carbon group that's being oxidized. Therefore, this is called an oxidation. Now, here are a few other reactions for you to look at. First of all, assign oxidation numbers to all the different elements in here. Notice that that's an element sodium, and it's an ion sodium, and carbons, hydrogens, nitrogens, and so on. And once you've done that, then see what's changing and see if this is an oxidation or a reduction or neither. Not all reactions are redox reactions. So you might want to pause the video and work on that one and see what you come up with. This is a familiar reaction. It's one you learned back in the alkyne chapter. Remember, if you take an alkyne and react it with sodium and liquid ammonia, you add 2 hydrogens across the triple bond, it becomes a double bond, and you always get the trans isomer in that case. So that's a familiar reaction. See if you think that's an oxidation or a reduction or neither. Moving on to this one, this is a free radical halogenation, another familiar reaction. Again, assign oxidation numbers and see if this is a redox reaction or not. Again, you might want to pause the video at that point and work on it. And after you're done with that, work on this one. This is just an Sn2 nucleophilic substitution, where OH minus is acting as a nucleophile. It's coming and attacking that carbon, pushing that to Br minus, so you get an alcohol and a halide. See if that's a redox reaction or not. And then take a look at this one, which is a hydration of alkenes. Again, a familiar reaction you're used to. Typically, this would require an acid catalyst, but one thing to notice is catalysts don't matter in redox reactions. Whether there's a catalyst or not doesn't affect whether the reaction is a redox reaction or not. In any case, assign oxidation numbers to all of the elements here and see if anything has changed and if therefore it's a redox reaction or not. Finally, let's take a look at this ozonolysis. Again, a familiar reaction to you. Now, one thing I've done here is this is normally a 2-reaction 1-pot synthesis, where first you react the alkene with ozone, and then in a second step you add dimethyl sulfide as a reducing agent. I've combined it into one reaction so that we can see what's actually changed, and notice that the dimethyl sulfide turns into dimethyl sulfoxide, and the O3 is the 3 oxygens are distributed between these 2 oxygens and that one right there. So again, assign oxidation numbers and see what's changed, if anything. Identify the oxidizing agent, the reducing agent, what's being oxidized and what's being reduced. That's it for now. Thank you.